Group 17 elements. Atomic and physical properties of halogens. Observe the variation in atomic or ionic radii. It increases down the group. The halogens have the smallest atomic radii in their respective periods due to maximum effective nuclear charge. Atomic and ionic radii increases from fluorine to iodine due to increasing number of quantum shell. Now observe the variation in ionization enthalpy. It decreases down the group. Halogens have little tendency to lose electron. Thus, they have very high ionization enthalpy. Due to increase in atomic size, ionization enthalpy decreases down the group. Now observe the variation in electron gain enthalpy. It decreases down the group. Halogens have maximum negative electron gain enthalpy in the corresponding periods. This is because the atom of these elements have only one electron less than stable noble gas configurations. Electron gain enthalpy of the element of the group becomes less negative down the group. The negative electron gain enthalpy of fluorine is less than that of chlorine. It is due to small size of fluorine atom. As a result, there are strong inter-electronic repulsion in the relatively small 2p orbitals of fluorine, and thus the incoming electron does not experience much attraction. Now observe the variation in electronegativity. It decreases down the group. Oxo acids of halogens. Due to high electronegativity and small size, fluorine atoms forms only one oxo acid, that is HOF, known as fluoric acid or hypofluorous acid. You can see here the various oxo acids of chlorine. Chemical properties, oxidation states and trends in chemical reactivity. All the halogens exhibit -1 oxidation state. However, chlorine, bromine and iodine exhibit +1, +3, +5 and +7 oxidation states, also as explained below. The fluorine atom has no d orbitals in its valence shell and therefore cannot expand its octet. Being the most electronegative, it exhibits only -1 oxidation state. The higher oxidation states of chlorine, bromine and iodine are realized and mainly when the halogens are in combination with the small and highly electronegative fluorine and oxygen atoms. The reactivity of the halogens decreases down the group. The ready acceptance of an electron is the reason for the strong oxidizing nature of the halogens. F2, that is fluorine, is the strongest oxidizing halogen and it oxidizes other halide ions in solution or even in the solid phase. The decreasing oxidizing ability of the halogens in aqueous solution down the group is evident from their standard electrode potentials, which are dependent on the parameters indicated below. That is dissociation enthalpy, electron gain enthalpy, and hydration enthalpy. Anomalous behavior of fluorine. The anomalous behavior of fluorine is due to its small size, highest electronegativity, low FF bond dissociation enthalpy, and non-availability of d orbitals in valence shell. Most of the reactions of fluorine are exothermic. Due to its small size and strong bond formed by it with other elements. It forms only one oxo acid, while other halogens form a number of oxo acids. Hydrogen fluoride is a liquid having boiling point 293 Kelvin due to strong hydrogen bonding. Other hydrogen halides are gases. Reactivity towards hydrogen. They all react with hydrogen to give hydrogen halides, but affinity for hydrogen decreases from fluorine to iodine. The acidic strength of these acids varies in the order Hi greater than HBr greater than HCl greater than HF. The stability of these halides decreases down the group due to decrease in bond dissociation enthalpy in the order HF greater than HCl greater than HBr greater than Hi. Reactivity towards oxygen. Halogens form many oxides with oxygen, but most of them are unstable. Fluorine forms two oxides, that is OF2 and O2F2. However, only OF2 is thermally stable at 298 Kelvin. Both are strong fluorinating agents. A combination of kinetic and thermodynamic factors lead to the generally decreasing order of stability of oxides formed by halogens, that is I greater than Cl greater than Br. The higher oxides of halogens tend to be more stable than the lower ones. Chlorine oxides, that is Cl2O, ClO2, Cl2O6 and Cl2O7 are highly oxidizing agents and tend to explode. The bromine oxides, that is Br2O, BrO2 and BrO3 are the least stable halogen oxides and very powerful oxidizing agents and exist only at low temperatures. The iodine oxides, that is I2O4, I2O5 and I2O7 are insoluble solids and decompose on heating. I2O5 is a very good oxidizing agent and is used in the estimation of carbon monoxide. Reactivity towards metal. Halogen react with metals to form metal halides. The ionic character of the halides decreases in the order Mf greater than Mcl greater than Mbr greater than Mi, where M is a monovalent metal. If a metal exhibits more than one oxidation state, the halides in higher oxidation state will be more covalent than the one in lower oxidation state. Reactivity of halogens towards other halogens. Halogens combine amongst themselves to form a number of compounds known as interhalogens of the types XX-, XX3-, XX5- and XX7-, where X is larger size halogen and X- is smaller size halogen.